Good evening, everybody. Tonight's video is going to be about the greatest integer function, which is another one of those functions that we talked about the other day with our packet when we had the family of functions. But this one always seems to be a little confusing for students to grasp at first, so I thought it might be a good idea to give it its own video. So before we talk about the function itself, let's talk a little bit about integers. And remember that they are positive and negative whole numbers, including 0, but they don't include any numbers with decimals or anything that can only be written in fraction form. So integers are numbers like negative 27, negative 9, negative 2, 0 we said is included in the set of integers, 1, 4, 18, etc. Okay, so it's going to be positive or negative. Could also include 0, and it's going to be just whole numbers there. So not integers would be numbers like negative 0.25 or 1/3 or something like 3.78, that sort of thing. So any number that has decimals or fraction form only, that would be, we would call those non-integers, okay? They're still real numbers, but they're not part of the set of integers. So when we're talking about the greatest integer function, it's going to have values that are only integers. And remember, when we're talking about the value of a function or the value of f of x, we're talking about the y values. So the y values here are only going to be integers. And so what that ends up making our graph look like is like a set of stairs, because along the y-axis, we're only going to have the graph where there's the whole integer values. So in between those, where it's all decimals, we're not going to have anything. And I'll show you that in a second. So sometimes, like I said, this graph looks like a set of stairs. So sometimes you'll hear this referred to as a step function. And the dogs have come up, so I'm going to pause this for a second and take care of them. So hang on one second. Okay, sorry about that. So greatest integer function is going to look like a set of stairs when we draw it out, so that's why it's called a step function sometimes. So let's set up like we have in our packet from the other day, the name of the function, its domain and range, its description, then we'll make a table and we'll graph it. So first of all, f of x, you'll see this written a couple of ways. Some textbooks will just say int x, which if you want to use your graphing calculator, you'll go to a menu and you'll see the int button. You'll also see an abs for absolute value if you ever wanted to graph that. But you'll see it written as int x, or you might also see this written as f of x, and then it's like a bold bracket. So it's got the bracket and then like another line right here. So enclosing x. So those are the two kind of notations that you'll see for representing the greatest integer function. And it means the greatest integer less than or equal to x. So for example, if I were to take, and we'll do this when we fill in our table for the graph. So the greatest integer function of the number 4.5. So if I were to plug in 4.5 to this function, I want to know what the greatest integer that is less than or equal to 4.5. So the greatest integer that's less than or equal to this. So the greatest integer that is less than or equal to this is 4, because if I had 4.5 is between the integers 4 and 5, and this one it's the integer that is less than or equal to that is 4, right? Because 5 would be greater than 4.5, so that's why 4 is the answer there. And just remember that if we had something like negative 3.76, when we're talking about negatives, the greatest integer that is less than or equal to that, this would actually be negative 4, because negative 3 is greater than negative 3.76, so negative 4. So if we're in the positive integers, we're kind of like rounding down to the lowest number that I see here. If Same thing with negative integers. I'm kind of like moving down the y-axis, so this would be -4 instead of -3. Okay. So name greatest integer function. The domain is all real numbers, so I can plug in anything I want into the function, right? So all the x values can be anything that I can plug in here, because what's going to come out of this is going to be only integers. That's why the range is all integers. So no matter what number I put in here, I'm going to get an integer as an output. So the domain is all real numbers, but the range is all integers. And to describe this, I would say the graph of the greatest integer function looks like a series of steps or a series of small constant functions. And remember, the constant functions were just horizontal lines. So I'm going to see a bunch of horizontal lines here that are along intervals that are going to be open on one end and closed on the other. And so we'll see that when we make a table here, what's going to happen. So if I have the table and the sketch of the graph of the greatest integer function, I rescaled this graph so it might be a little bit easier to tell what's going on here when we plug in our table values. So let's pick, we've been using -2, -1, 0, 1, and 2, but let's pick some non-integer values here to see how this works. So if I start at -2.5, -2, -1.5, -1, 0, we'll do 0.5, 1, and 1.5, and that should give us enough to figure out our steps. So the greatest integer function of, if I plug in -2.5, and remember we said for the negative numbers, this is going to be the greatest integer that is less than or equal to this. So -3 is less than or equal to -2.5. Okay, and then at -2, what's less than or equal to -2? Well, that would be -2, because remember, it can be equal to from our definition of the function. Okay, so then moving down to -1.5, the greatest integer that's less than or equal to that is going to be -2. And at -1, the greatest integer less than or equal to that is -1. At 0, remember we said that 0 is an integer. Okay, so that works out there. At 0.5, the greatest integer that's less than or equal to that is 0. At 1, integers that are greater than or equal to that, it's 1 because that's equal to. And then at 1.5, the integer that's less than or equal to 1.5 would be 1. So now if I plot all these points, -2.5, -3, that would be down here. -2, -2 is right here. -1.5 at -2, right there. And then at -1, -1 is right here. And 0, 0 is right there. 0.50 is right there. 1, 1 is right there. And 1.5 is right there as well. So I can kind of see the steps, the pattern that's forming here. But what I left out is that okay, so from here, it's pretty easy. I at least connect those with the line. At here, this would be like -1.25. That would also give me a point down here at -2. Because it's got to be less than or equal to that. So it's going to continue. This step is going to continue until it gets to right here, and that's when it's going to make the jump up to the next step. So that's why you'll see these steps will have a closed end right here, and then there's an open end here because it's continuous over up until this point where it switches up to the next step. And so then the point above this open one is going to be filled in at the next step. And so that's what we're going to do all the way up. So we're going to see that it looks like a bunch of constant functions or little horizontal lines. And it's going to step up along the integers. And at the beginning of the step, it's filled. And at the end of the step, it's open. because right there is where it moves up. So it's like saying that you can't have 2 feet on the same stair or on 2 different stairs. You can't have both your feet on 2 different stairs at once, right? So there's always an open dot or open point below the start of the next stair. So that's what a sketch of this graph looks like. And so here are all my steps going up across. Okay, so this might be a little confusing at first. We're going to do a little more practice with this in class tomorrow. But you can add this if you want to on the back page of your packet, or you can just have this in your notes if you've already put it in your notebook. And when we come to class tomorrow, we'll do a little more practice with this, and I'll see you then. Have a great night.